Hello, this is Rob Hirschfeld with another Digital Rebar provision video. This one about installing Kubernetes using KRIB, our Kubernetes Rebar integrated bootstrapping content pack, and we're going to walk you through it. This video is designed as a follow-on for building a 3-node cluster. In this case, I used packet.net because I can do the full networking, reboot install process, which I showed you how to do, and Packet really has minimal network security, which is a benefit when we're trying to pull all this stuff together quickly for a prototype. So we're going to go ahead and do that. This is Digital Rebar, and here I've already jumped through the quick start process and set up my machine, which I have running over here. So I have 3 nodes set up for a Kubernetes demo. I have another one that hopefully you'll get to see a K3S demo. I did a K3S demo using Ansible. We're going to do a K3S demo using KRIB. It's a tease. You'll get to see that hopefully another time. This is just about setting up real big Kubernetes. And so these are the servers that I have running in Packet. This is my Kubernetes workflow with just the basics. So I've got the machines, they're in Sledgehammer weight, everything's ready to go. And in this Kubernetes demo, what we're going to do is we're actually going to install into Sledgehammer. So instead of installing an OS on disk and then going, I'm going to do a live boot, what we call a live boot, where we actually attach the disks but keep the operating system running in memory and do all the install against that. So if I want to flush the cluster, I literally can just reboot the machines and all of my installs are gone. Very, very handy for rapid prototyping, and depending on how you want to run your data center, it might be a model for you too. So in this case, if we come into our documentation and we type KRIB, what you'll get is a couple of options for how to install KRIB. If you click the top one here, it's pretty straightforward. This has some actual information about exactly what we're doing, and I'm going to walk you through that process. But this isn't where I'd recommend you reading the real documentation. In this case, if you go into the modular, the content pack documentation, it has a lot more in it. So it has our videos, it has a lot of the same information about how to set it up, but very importantly, it actually has all of the documentation for all the parameters and pieces and parts and things like that. And I'll come back to this because I want to explain it in a little bit more detail, but it's also going to take us some time to install Kubernetes. So without further ado, let's get started. So there's a couple ways you can do this. I'm going to show you a CLI version because it's super handy to know how to use the CLI, but everything I'm going to do, you could also do from our content and catalog view. So I'm going to need like our certificate manager, our Kubernetes pieces, and I'll show you what that looks like to install. But from this system, I can also do it right here. In this case, this is the actual server where I have the machine, DRP CLI, machines, list, JQ. This is the 3 machines, so this is local. If I want to do it on my own system, which is not a bad idea for us to show, so instead of running it from the local system, what I'm going to do is I'm going to set things up here so you can actually run it yourself. So to do that, I need the DRP CLI. I'll let you read the instructions for that. I've already installed it. RS endpoint, RocketSkates endpoint equals HTTPS. This is my endpoint. Grabbed it right off the URL. And I also need to set my RS key, which is my credentials, which is RocketSkates, because I haven't changed the defaults. And the password ROCKETSK8TS. And so if I do that and say DRP CLI info get, I will see that I actually have access to the system. Oh, that's great. And so let me make this a little bit bigger so we don't run off the screen. And then what I need to do to install the DRP the content is I can actually use the Digital Rebar catalog. So I can say Digital Rebar CLI contents. I want to upload KRIB. I want to upload from the catalog actually. So catalog, KRIB, and I'm going to get the tip version of KRIB. So if I do this, it's going to go out to the rack and catalog. It's going to look up the location for KRIB and then pull down that content pack online. Our UX does exactly the same thing behind the scenes, so this is equivalent to me coming into KRIB. So if I click Kubernetes to see the filter, I'll see KRIB right in here. I could also search for it, picking the tip install, and then going ahead and telling it that I want to install it. But you'll notice here it's actually missing the prereqs, and we're about to be told in this the exact same thing. It's going to come in and say, wait a second, I can't install that because I am missing, if I hover over here, it's going to tell me the certs plugin as a content pack. I'm going to get exactly the same error here that certs is missing. So what I want to do is I'm going to use the UX to install the certs plugin. It's right here. Download, click download in here, and it's going to do exactly the same thing. It's going to the catalog, it's checking the catalog location, it's pulling down the appropriate version. In this case it's binary, so it's going to pull down the appropriate architecture version 2 for the Linux backend that I'm using. Now if I repeat this step here and install KRIB, it will come through and add KRIB for me into the system because the prereqs are now met. And so what that'll do is you'll actually get to see that come through in the provisioning API here once it's added. And what happens when we install KRIB is it's going to come through with a ton of content. So I think there's 100 parameters that you can set for KRIB. You only need 2 to actually install it. All the other defaults work. But we'll define a profile. It's also going to build workflows and stages and templates and tasks. KRIB has a ton of things in it, and actually I'll show you those in a minute. Right now what we're doing is the API is loading all of this content, so our refresh is going to take a little bit of time, which it did. So what you'll see, if you remember this from the last video, there were only 4 workflows. Now there's a lot of workflows because we have all these KRIB install live clusters, install, and things like that. We're actually in the process of rationalizing some of these things, and you'll see some of these workflows start collapsing in some of our standard process. But we want to install Kubernetes, so let's get to it. So I'm going to jump in here, and I need to build a profile to hold all the Kubernetes information that I've got. So in this case, I'm going to start with the example KRIB. I don't have to start with the example, but it's handy because it has some extra metadata that I'm going to want to take advantage of, like this Kubernetes is installing thing up at the top. I'm just going to call it demo. And then I have to name, this is a cluster pattern that we use in Digital Rebar. I have to put the name of the cluster in the profile that I'm using to build the cluster in the cluster. So the etcd cluster profile, etcd KRIB profile. I could split those. In this case, I'm just doing defaults. So I have 2 clusters I'm building named demo using the profile demo. And then I'm going to go ahead and use a red icon just to make it more noticeable. So here is my demo profile, and you'll see it just has those 2 pieces of data in it. That'll change as I do the install. To make it actually work, very straightforward. All I have to do now is take the machines I want to build into the cluster. I have to assign them that profile. So that means these 3 machines are all sharing this profile. That profile is now our cluster profile, and all I have to do to make things work is go ahead and start the workflow to install the cluster. So in this case, I want a live cluster. I'm installing right into Sledgehammer. And I could be using other operating systems like CoreOS or Rancher, things like that. We've actually proven this stuff works against tons and tons of different operating systems. But what you'll see happen is we're immediately starting that workflow. It picks up and starts, and it's going to go through, and it's giving me live updates because that's what Digital Rebar does. I'm running a whole bunch of jobs to implement that workflow. If I jump into one of the nodes over here, I'm going to hide this. What you'll see is it's going through this task list. So the workflow decomposes into the tasks. The tasks are what's doing the install, and each one of these tasks is executed in sequence. We're already into the Docker install piece. It's a pretty slow step. If I want to, I can jump in and see exactly what's going on in that process. So in this case, here's the Docker install piece is working, and we're just going through and doing the yum install utils, and it's going to take however much time it takes to do that process. The installing Kubernetes is actually the configuring Kubernetes is actually the short part of this process. The installs are going to take some time, where you actually have to download all the pieces and parts and things like that. Now, remember, Digital Rebar here is running in the data center, so all of this stuff, I'm not connected to it. I don't have to keep a connection. I'm not SSH'd. It's literally a service running in the data center. That's what the endpoint does. And each one of these systems is operating in parallel, talking to that endpoint. So it doesn't matter if I'm connected, if I disconnect, if I walk away, if my connection gets futzed, systems are still going to run. It's all self-contained in the data center. And as progress gets made, we're going to see these things update live What I wanted to do is I wanted to jump back to the topic that I told you about, where I was showing you in the documentation. We have things like different parameters. So if I wanted to change the configuration for from Docker to containerd, I could actually find the runtime in this params list. Let's find it somewhere down in here. I can't make these bigger. Somewhere in here is the actual container runtime, so let's find it. This one's a big one, so it actually has quite a bit. Containerd. CRI. You can see how many things are actually here. There's actually a variable KRIB container runtime, and this is used to set the Docker or containerd runtimes in the system. So if we jump over here and look at the GitHub for this, so GitHub digital rebar provision content, and go into KRIB, this is the actual source of where the Kubernetes install is. And if I jump into parameters, what you'll see down here is I can scroll down into the Kubernetes container. Let's see, container runtime, where is it? Somewhere, let's say, hold on. KRIB container runtime. Am I in parameters? I am. It should be alphabetical, so I'm in the wrong spot. And I'm blowing past it, and everybody's like, "Wait, Rob, you blew right past it." Somewhere. Here's KRIB container runtime. Phew. And what you've got now is, here's the container runtime, here's the documentation line that you just saw, but more importantly, there's things like it's a string, it's actually an enum that's limited to these two values, so you can only pick those two things. The system's going to stop you if you try to inject cryo into this, and it's not supported. So all these things are sort of wired together. So self-documenting based on when you add parameters. You can of course build your own content packs, but the nice thing is, as the community adds into this, it's easy for them to add documentation. They don't have to do documentation separate from actually adding the capabilities and the variables and parameters. So parameters are going to be self-documented. Super important to me as we go. Some of these have quite a bit of documentation behind them, and a lot of stuff we do shows up there. Just great practice. I'm really excited to see that. In this case, what you'll see, I'm jumping back to see where we are. Here we've got the system moving forward, so we're in Kubernetes install for some of these pieces. If I was to jump back, and this is sort of fun, into the stage, let's see what we get. I've done this a couple times, which is sort of fun, and we actually collect data back about what's going on. So as things are running in the system, they all decompose into tasks. Tasks are logged as jobs, and every one of those jobs has a execution date. So in this case, we can actually come back and see for this stage, we've had multiple runs. And in those runs, I had a couple failures in my testing, and then it's been working, and I can actually see how long it takes it to run that operation. And if I want, I can jump in and see exactly what happened, where it went. If I wanted to, which is even more cool, I could jump in and say, "Oh, what happened?" and let me see where the failure was, and I can figure out what happened and what broke from that perspective. And of course, I can come in and see not just the job results, but I can see the script that rendered it. The rendering scripts are not kept if once the jobs are changed, and so this doesn't always give you reliable results. But if you're testing and debugging, this is an invaluable tool to actually see what got run and what all the values are, because sometimes things get tricky. And of course, here's the live view of jobs that I have running in the system, and I can jump back and check out any one of them and see what's going on. So in this case, this is one of the workers, so it's not running. We're waiting for Kubernetes install to go, which is exactly what you'd expect. Actually, this one is taking a little bit of time. It just finished, and now they're going through etcconfig. One of the things that I like to do, and we show in color demo, is changing the icons, so it's very clear to me, even when I'm running the system, which machines have been elected as the leaders of the cluster and which ones are just the workers. In this case, these other machines are waiting for the system to generate a token, because we're just using Kubeadmin under the covers. And so once this is done, that token is going to get written back into the shared profile and release the work on the other machines. So let me show you what that looks like. Over here in the profiles, there's a couple ways I can navigate to it, but here's my demo profile. You'll remember this only had 2 things in it before. Now it's got quite a bit because it's been running. So it's the etcd cluster, the certificates, the passwords, all sorts of things have been written in, the peer name. So the etcd cluster is fully built. And then even things like the bootstrapping token is now here. So that means the install is continuing. And this is a really important point. So we didn't start this cluster build with any information. We started it actually with nothing except saying these machines are in a cluster together. And Digital Rebar, in running these workflows, elected a master, collected the information, made all this stuff come together, and then wrote that data back as it was built into the API. So as a consumer of this API, I could literally write automation that consumed this profile and watched it, got events that are coming off of the system, tracked it, looked at shared data. So I didn't need to run a system and predefine anything. I could literally let the workflows figure things out, collect data about the system, and then push it back into that shared profile that became a cluster. So if I wanted to add another machine into the cluster, I could easily spin up another machine in the cluster, which I can actually demonstrate for you. I'll just grab my K3S machine. I have to put it in the profile so it sees the shared data, but all I have to do is come in and add it to this cluster, and it's going to go through that process. And now that that data's there, it's just going to pick up the token and go. So I'm literally going from a 3-node cluster to a 4-node cluster. One thing you'll see, I have a red X, which means something broke. Kubernetes dashboard has changed, and we haven't updated the code for that. So this step is going to fail. If I click in here and scroll to the bottom, it'll actually be pretty clear. It's trying to reach a YAML file in a GitHub repo that's no longer there, saying, hey, there's 404. This doesn't actually break. It's a downstream thing, like our Helm charts or things like that. Kubernetes is actually set up here. So if I jump into that shared profile, you'll see we actually have some UX friendliness that says, oh, I can just get my Coop Cuddle ADM file, which I'm going to do. So I'm going to take this file. Let's see. And, oh, good. It looks like it's just admin conf. Went to my downloads file, but I'm going to show you what that looks like to you. So here's the Coop Cuddle command that it's telling me to use. That sounds pretty cool. And I'm going to copy over from downloads admin conf. I think that's the right one, to my local system. And then I'm going to go ahead and Coop Cuddle this exact line. Whoops. Yep, it just brought it down a second time. All right, so if I do this, and then I say, let's see, get nodes, or is it? I always get this backwards. Is it nodes get? I think. I haven't installed Kubernetes on this system. That's pretty straightforward. I don't know. Let's see. Yay. Don't you love it? I'm going to pause and get this installed and then show you how it works. All right, helps if you read the screen, which I just did. So now I have Coop Cuddle. And if you're a Coop Control or CTL version, sorry, I'm not. I'm recording. So Coop Cuddle is installed now, and I'm ready to go. So I can just scroll back up and let it actually do its thing. And of course, it's get nodes. So all that work to show you this one thing, but this is the right thing to do. So what's happened is I built this cluster. I want to control it. I generated the admin conf file, which has my credentials and everything else. That's the right way to access it. And then that's available in the profile. So when this cluster got built, we actually put the information in a shared location so that people with access to Digital Rebar can receive it. It also means that if I want to automate downstream from here, then I can retrieve that Coop Cuddle file and use it on the cluster. So I can run Kubeadmin, I can run YAML files, I can build things, I can do all the work I need to do because I now have access to the admin conf file in a shared location. And that opens up all sorts of great things. And if you don't like it there, you can delete it, just remove it, add a stage that removes it, stuffs it someplace else. Digital Rebar can use secure parameters, so this is not something that is just going to float around in the ether. It's in a secured, safe place. So literally, in the course of this video, with all this extra yammering that I'm doing, we were able to build a Kubernetes cluster straight out of bare metal live boot systems with pretty minimal setup and update, right? It just happened. And I'm not doing demo magic. This is literally easy enough for you to repeat. Just follow the steps in the video. And I just added a new node to my cluster. You'll notice here's the K3S machine, and that's good. One thing I do want to show you that's sort of fun is if I'm done and I've played with it and I want to repeat the experience, then there actually is even a reset. So I need to clear out a whole bunch of information from my system. So we have a workflow that clears that out. I only have to run it on one machine. I'm just lazy. I run it on all of them. And so it's going to go through, and when it runs this process, it's going to delete the certificates, it's going to clean up the profile, it's going to remove all that information. So if I come back over to my demo profile, what you'll notice is that we have removed all the other information, reset the cluster back. I could just put them back in the install workflow and repeat it. There's one thing I'd want to do first. I'll show you what that is. But in this case, we're just now back to a clean system, and all that data that we had collected is gone. So that cluster no longer exists. Actually, I suspect no, it's done. So we've literally cleaned out the cluster even more simply than we built it. If I want to reset the machines, what I would recommend doing here is I come in here, I want to go back into a discovery process, which is good. In this case, it's actually running it. I want to click this button, which also tells the machines to pause, set them back to discover packet, and then I'm just going to go over here and reboot them all. There we go. And since this is a live boot, that's literally wiping the OS. So it's going to reboot. It's going to start with a completely clean OS, and that's going to be the system ready for a complete reinstall. So at this point, profiles are set. I just have to go in, run the live cluster again, and repeat the process. Apply, rinse, repeat. And that's really one of the valuable things that we like to do with Digital Rebar, is to make this system able to spin, repeat, rehearse, because that's how you get ops right. You don't do it the first time and everything works. You have to continually refine your automation with iterations. Systems designed to make that as easy as possible. Wow, I hope this was helpful. We're really proud of Digital Rebar, of course, and also of just how much capability KRIB has had. There's amazing work going on in the community to make this robust and secure and very resilient with a lot of configuration options. So please check it out. Take some time to investigate all the different bells and whistles that you can have with this, with KRIB and Digital Rebar itself. If you have questions, please come into RackN, join our Slack channel, and be one of the operators that are discussing how to make data centers a better place.